Let's take a look at example 4 now. We're going to compare these 4 bar graphs, A, B, C, and D. And we're going to take a look and try to figure out what the standard deviations are in order from smallest to largest. Even though we're not given the value of the standard deviation, we should be able to look at the graphs and figure it out based on our understanding of what a standard deviation is. So just remember that a standard deviation measures how spread out the data is from the mean or from the center. So we want to order this from smallest spread to largest spread. And because the standard deviation is a number that represents the spread, the smaller the standard deviation, the smaller spread there's going to be. So the values of the data set are going to be more clustered and centered around the mean. So looking at graph A is very compact. All the values are clustered around 5 with just a small spread or a small difference between 4 and 6. And this suggests a low standard deviation. And if you compare it to the other graphs, I would call that the smallest standard deviation. So if I'm ordering this from smallest to largest, I would say graph A is the smallest. Now look at graph B. It has more values spread from 3 to 7. It's still centered at 5, and it's still pretty close together around 5, but the spread is just a little bit wider than graph A, so the standard deviation should be slightly higher than graph A. So I'm going to call this the next biggest standard deviation. When we look at graph C, it goes from 2 to 8. It's still centered at 5, but it goes out even further this time. So graph C is going to be the next highest standard deviation. And graph D is the most spread out. It goes from 1 to 9. It's still centered at 5, but it's spread out the furthest from 1 to 9. So this is going to have the highest standard deviation. Now let's look at another comparison between graphs. For example 5, we're going to compare normal curves, which is that smooth curve that has the bell shape. We have the red curve and then we have the dashed blue curve. The first question says, which curve has the smaller mean? Now remember, the mean is the center, so we're looking at the tallest peak, or the area where the majority of the data lies. Now, for the blue graph, the mean is going to be at 4. For the red graph, the mean is going to be at 6. So the blue dashed normal curve is going to be the one with the smaller mean. It has a mean of 4 compared to the red graph, which has a mean of 6. For the second part, it says which curve has the larger standard deviation. The red graph is spread out from about 0 to 10, while the blue graph is spread out about 0 to 8. Because the red graph is spread out between 0 and 10 versus 0 and 8, and it's wider, then the red graph is going to have the larger of the standard deviations. Let's go over some final tips for this lesson. Number 1, you always want to check when you're doing your calculations for mean or standard deviation. Always check and make sure you understand if the calculations are based on a sample or population, because that's going to indicate where you get the information and what symbol you're going to be using to display the data. Another thing that I want to point out is we talked a lot about the 5-number summary in the interquartile range. And one thing that I didn't mention while we were going through the example is that the IQR is a really good way to understand the spread of the data without being influenced by the outliers. Remember, the outliers are going to come out way past, and they're going to be in the whiskers, the max and the min. But when we're looking at the spread of the middle 50%, we're not using any information that's going to be on the extreme left or extreme right. We're only looking at the middle 50%. So the IQR is a good way to understand how spread out the data values are without being influenced or misleading because of any outliers. And the last thing I want to mention too is the range is a quick way to estimate how spread out the data values are. However, the spread can be really misleading if you have outliers. So remember, the range is the maximum minus the minimum. So if you have an outlier, that might change the range drastically. So for example, if I had a data set that had a bunch of numbers in it from 1 to 5, let's say I had 12 in the data set as well. That's an outlier. Everything else is between 1 and 5, but that 12 is an outlier. So if I take the range, I'm going to have 12 minus 1, which makes me think that I have a spread of 11. But if you ignore the outlier, the majority of the data lies between 1 and 5. So we should be looking at a spread of about 4. That outlier, that one data value, will change or mislead you on what the spread of the data values are. So be careful when you're using the range. It's a quick way to get a sense about the spread, but remember, it can be misleading.